Okay, hello everyone. So today let's solve equal to question 5, longest palindromic substring. And this is quite great example to use the algorithm called the monikers algorithm. And this is the algorithm to find the longest substring, longest palindromic substring. So like counting palindromic substring or anything that related to palindrome, this algorithm is useful. And the thing is, when you try to solve this question, like intuitively, it takes all n squares because, so let's see, so you want to find the longest palindrome here. And how would you do it without this Monaco's algorithm? Well, my first idea is to look at this B and then trying to expand it. So the B is the center of palindromic, and then you keep expanding it as long as it's palindrome. And then the same thing is A, so B and B is the same, so BAB is the new palindrome, and that's the maximum you can go, and then B is now center, and ABA is a new palindrome, so you can expand it. But BAD is not palindrome, so ABA is the maximum, and then you keep shifting it. And you also have to check the case where you start with two characters at the center. So BA is the center. So this is actually a good example. So BB is the center, and C and D is not the same, so BB is the maximum. So that's how you find it. So you have to go through all the strings every time, like for every centers, so that is going to be n squares. And this Monaco's algorithm instead, it can solve these type of question is ON, so which is really quick, linear time. So how would you do it? So let's see this example. Okay, first, let me show you the first step, the very first step of this Monaco's algorithm. So, which is to insert this hashtag or sharp to every, partition of it. Every, like between every characters, you put this sharp. And at the end, you go into this sharp and like this is just a random values. As long as it doesn't include it is not included in the original string, it can be anything, and this dollar sign. And it's very important to make this and this dollar signs and this. I don't know how to even call it, but you differentiate them. So what's the reason behind this? So the reason is make every palindrome to make this is odd lengths, so the problem was when you do this, when you make a center with the one characters and two characters, it always so you have to check two patterns basically. You have to check um the case when you have one character at the center and then two character at the center. But if you insert this curve between them, so imagine this, so let's make another example, B, A, B, and you insert all the sharp between them. So B sharp, A sharp, B. It is okay because it's already odd numbers, like 3. So it doesn't matter, you still have U, so the maximum palindrome would be this that starts from A and then sharp is the same, and a B and a B. So this is the maximum. So it's normal. But let's now think about the even case, A, B, B, A. And obviously, so this entire string A, B, B, A is a maximum palindrome. But you have to check the two characters at the center. So BB is the center, and you expand the AA, and is the same character, so you can, include those AA into the final result. But by inserting sharp between all the characters, this sharp is actually going to be another center. So this is the center of this palindrome, like when you convert it to this with sharp. So this is the center, and the BB is the same, and AA is the same, and then finally this sharp is the same. So it's just, I mean, when I first saw this, it was really confusing because like why, what the hell would you do that, right? But it just actually you want to handle everything as old case, like one character at the center, and that's the main reason. And I want to talk about a little bit more about this chirp and this dollar signs and like the random mark. Why did you want to do it? Like what? Okay, so why doesn't can be like this, like the opposite? This weird sign is the front, and this is the first. Why cannot do like that? It's because so let's think about the first the case when you have only one characters. So like this, okay? So I am going to explore the entire logic later, but basically, if it's the opposite, so it's gonna be so like this, sharp here, and this is going to be this one palindrome, even after you convert it. Just this single A, it's going to be um, just the palindrome. But after that, you see later, because we insert this weird thing sharp between them, you want to, make the size hard, like kind of cutting all the sharp at the end because obviously at the end we want original substring, palindromic substring um, without these sharp characters. So to do that, we're going to make the half. So it cannot be just one character A. We have to be at least create the length of three palindrome like this. So if I make something like this A is obviously the part of palindrome, and this sharp is also the palindrome. So it's kind of the length of three, and it can be expressed as max radius one later. So it's a quite like the few trick to avoid like some edge cases. Okay, so now let's dive into the actual logic with this graph. It actually I got this picture from Medium website. I'll keep the link of the original articles in the description. But basically, you are keeping track of some variables. So first things first, the radius. So I'm calling it poly radius, but it's just the radius of palindrome. So let's see the actual example. And then it's a list. So you want to keep all the radius from each index. And then remember, it's all the palindrome is going to be like one character at the center. So you don't have to think about, the two character at the center. So just any size. So let's imagine this example. Let's imagine you are at A, index one. So what is the radius? The radius is um, so the first you find the palindrome, and in this case, it's not the palindrome. I mean, one single character can be considered as palindrome. So in the real case, I mean, this in this example, you have sharp between them. So you have sharp between this. So actually palindrome is, sorry, radius is one because you have this sharp around the A. And then, by the way, as a radius, you don't include SA. So let's go to the next step. So let's imagine this center B. You're here. And then you have sharp, and a B, and then this is also palindrome. So B and B is the same. And you have sharp here, even between A and B, and here, and A is the same. And then you have sharp between this A and C as well. And then eventually the C and C is the same. So what is the number, I mean, what is the radius that like for index 3? 1, the sharp, and 2 for this B, and 3 for this sharp, and 4 for this A, and this 5 for this sharp, and then C for 6 for this G. So eventually, this radius is going to be 6, right? 6. But actually, if you see the original string, it's 3, the A, B, A, C. But don't really worry about it. So with sharp, the radius is 6, and that's how you calculate it. So, but you want to speed up this calculation. Basically, um, why we want to keep this radius, it's because you want to speed up um, the process of finding the next palindrome. And here's the technique. So, and it's actually like this, like the mirror index is something that is related to find, um, the next palindrome very quickly. So let's imagine that you're here. Is A? Yes. Okay. And because you already calculated all the radius, it's from here and here. I mean, at the very beginning, from the very beginning to the very last index, 0 to 6. So what can you use? How you can utilize this information? So you are inside of the palindrome. So now this you're at index 5, and because you expanded the radius at the center B until 6, this index is 5 is inside of the palindrome, okay? Inside of the big palindrome. And we are keeping track of the centers, and then right, this is actually right. Do we have information for that? Okay, so give me a second. So we are going to keep track of what is the maximum palindrome and what was the center and the right index. And then now in this example, the B was the maximum palindrome center so far. And then index 6 was the maximum palindrome index in the right on the right side. So it's so now you're at index 5, and it's part of the big palindrome, starts from 0 to 6. And based on this information, what you can tell, um, what you can tell is, so you check the other side of this palindrome. Okay, so this A, it's so you check this A. Okay, so it's also the other side of palindrome. Okay, so because it is a part of palindrome, and this are same, and this and this are also same. This is the same, and um this and this are same as well. So in this case, because you're at A, what if, let's say, this C is actually B? In that case, this A actually has radius 2 because we have sharp between here. And then, you have B here, so the radius 2. So you can tell that based on this information, you you also have B here. Sorry, it's hard to see it. You have B here, and then sharp, sharp. Can you imagine that? So when you check the mirror, I mean the same distance from center, and then you check the location, and then you check the radius because we keep track of all the radiuses at each index. You know like how much radius it had, and this at this index, and then what it had too. So that it means it it is so this and this are same. And because this is a big palindrome, this and this should be the same. So you don't have to check this anymore. You can just this and this are equally same because it's a palindrome, starts from here. But at the same time, the palindrome here, 0 to 2, are also equivalent to 4 to 6. Because you know what? This is a palindrome inside of the palindrome. This is a big palindrome, 0 to 6, and 0, 1, 2 is a small palindrome. And because it is a small palindrome, you can expect this 6, this like including sharp, um, this big another sided substring also has a palindrome. So you don't have to check anymore. You don't have to manually check. Oh, like this is B and yeah, let's say this and this is the same, or this and this and the same. You don't have to check it. So that's what I'm doing in the logic here. So if I is smaller than right, which means it is a part of big palindrome because the C was the right, um, and the center was this three. So it's a part of the big palindrome. You take the distance, so this distance, and then you get the mirror index, just like this, and then get radius. Okay, so don't worry about this. So for now, let's see this one. So radius at the mirror index. So you check the radius from here, and then you can utilize the radius to skip the check of this 4 and 6. Um, as a palindrome, you can start from B and maybe 7 if there's any other number. So that's how you speed up the process. And so now let's go back to why we have to do this, right minus I. Okay, so now let's think of this example. So we still have the big palindrome from here to here. And so because I change this index 0 to B, this is going to be the palindrome, this 0 to 2, 0 to 2. And also I put another B here before index 0. So this minus 1 to 3 is also going to be a palindrome. Okay. And then now think of another case. Let's now go back to this current index. And because the palindrome length is now what? I guess sharp here, 1, 1, 2, 3, 4. So the radius 4, radius 4. So can we go to, like, can we skip the radius that much? So that means you exceed this um, C and D and just starts from another, like, I don't know, A. But obviously, this D is not the palindrome here, B and D. It's clearly not. And the reason why is because, so when you start checking from here, it doesn't check until like this D. It stops right C, right? So there's no guarantee that this palindrome and sorry, this one and this big palindrome. So this is how many? So one, two, so one, two. Okay. So this big palindrome is equally the same. I mean, it's clearly not this and this is different. So when you check on the mirror, you have to make sure it doesn't exceed the right of the biggest palindrome so far. So in this case, you cannot exceed index 6. So that's what I'm doing here, right minus I. So we just pick up the minimum number from right I, either right minus I, or radius at the mirror index. And after that, it's really simple. So until radius, we guarantee that it's all palindrome ready. So based on I subtract radius plus one. So like unknown index, whether it's palindrome or not. And then right is I plus radius plus one. So now we are exploring some new fields. And then we keep doing this until it, resolve palindrome condition, like L and R are the same. And once it stops, this is the current radius, so I'm going to assign it. And if it's exceed right, that means you find another big palindrome. So you need to assign the new I. So the center is now I, and the right should be I plus the radius is at index I, or you can just R minus one. You can assign this as well. And then finally, because this is a finding the biggest palindromic substring, you find the maximum radius by doing and going through all the numbers and then find the index of it. And here's the trick. So now is the time when you convert like this really sharp string to the original index. So you want to calculate the length of the last result, like what is the actual maximum substring of palindrome. So because it's a radius, you have to multiply by 2 to get the actual length. So this is the max length of converted string, I mean T, okay, with sharp. And then now because we have sharp between the string, you want to make it hard. So divided by 2. So this actual length of palindrome, max palindrome is same as max radius because you just multiply it and divide it by 2. It's very important to note that why it's the same as max radius. It's actually you multiply by 2 because it's a radius and then divide it by 2 because it includes sharp. So remember that. And after that, it's really easy. The third index is going to be the same center index of converted string and then subtract the max length. And then you're going to divide it by 2. So that's the third index. And then return the result. So by doing so, you can avoid the worst case, like so what is the worst case that happens to this result? I mean, if you think about it, it doesn't happen often times, even in the brute force. So, when you have like just A and A and A and A, all the numbers, this is the worst case when you try to expand it, in the brute force solution, because you have to check this A as a center and you keep expanding it. And now this A is the center and expanding it, expanding it, expanding it. And this new A at the center and I keep expanding it. So the worst case of original solution was when you have the same characters like, over and over again. So this um, like efficiently is going to be avoided by this Monaco's algorithm by checking the palindrome inside of the palindrome. So you don't have to do this work anymore, and then you can just skip the radius until, like unknown fields, unknown index, so that it can go to like time complexity O(n). So this is quite a good, interesting solution, and let's run this course for now. Okay, so you can see this is pretty efficient solution. I hope you understand this algorithm well for now. It's a bit complicated, but once you're used to it, it's quite simple. It's not that complicated. And like as long as you remember this intuition, it's easy to code it up. So yes. So that's it for now. Thank you for watching. I'll see you in the next video. See you.